When we found the average velocity using this formula, what we do know is that S of t sub 1 is the same for every problem. It's S of 2, right? Which is 60.4. So if I set up the formula and I put S of t sub 2 minus 60.4, that's going to be in every single problem. And I also know that t sub 2 minus t sub 1, that t sub 1 is the same. It's 2 in every single slope. So I can put 2 in the formula. So what I'd like to do is figure out how can I get this on my calculator and use the table feature to evaluate this formula for various values, for the 3, the 2.5, the 2.1. So let's open up the calculator. We already have the function s of t in y1. S of t sub 2 is actually going to be my y1 of x, because our calculator uses x, and s of t is actually in y1. And I would subtract whatever 60.4 from that. T sub 2 is going to be x, right? Just like it was here, minus 2. So what I need to put this expression in for y2, and so I'll need parentheses around the numerator and around the denominator. So open parentheses, I go to vars, y vars, function, and enter because I want y1, open parentheses, x, and then close parentheses. So I have y1 of x. I have an extra set in there. I'm going to delete that. So y1 of x minus 60.4, which is the common value in each of the velocities, divided by, open parentheses, x minus 2, close parentheses. That's my change in time. The x is going to change. That is my t sub 2. And the t sub 2's, remember, go towards 2.0001. I'm going to go ahead up here and I'm going to highlight the equal sign on y1 and hit enter, and I'm just going to turn that off. It's still going to be used in this formula, but it's not going to show up in my table. We're going to go into the table feature, so second graph, and I have deleted all the values that were already there. I want to stress by putting these values in by hand again. So I'm going to put in all my t sub 2 values. So I hit enter for t sub 2. I get 5.5. Remember, y sub 2 is actually the formula for the velocity for each of these values. And so we got 5.5 before, we got 5.5 using this method. I want to try that with 2.5. I get 7.95, just like I did when I did it by hand. 2.1, I get 9.91. 2.01, the same value. 2.001, same value. Remember, if I highlight the number, I'll get more decimal places. All right, we'll come down. 2.0001, come up here and highlight, get the same exact value. I think I had an extra, just realized I had an extra 9 in there. And let's try one more value. Let's see if it'll take 2.000. I don't think this will fit, but let's hit enter. 0.4. I did. So that's the 10.399995. So this value that I had in here was incorrect. It's 10.39951. We'll get rid of that. And the 10.399951 would correspond to 2.00001. So either way, you can see that instantaneous velocity is approximately 10.4.